The first video in lecture 1 is about mathematical conventions. Now the first of these conventions concern mathematical abbreviations, and we will call this mathematical steno. Now what is the typical stenographical abbreviations that we consider? Well, the first is a sort of epsilon, which means element of. The second is the capital A upside down, which stands for all. The third one is a mirrored capital E, and it means there exists. And lastly, we have two symbols standing for and or. And is abbreviated by a V, capital V upside down, and or is abbreviated as a capital V. So the second topic concerns number systems. Now what is the simplest number system that you can think of? Well, this is just a collection of the numbers 0, 1, 2, 3, etc. We use the notation n for this set, and we call this the natural numbers. The second system is the simplest possible extension of the natural numbers, which we get by adding the negative counterparts. So we get the set 0, plus or minus 1, plus or minus 2, etc. These numbers are called integers, and they are denoted by a capital Z. Now how can we extend Z, the integers? Well, this is by the set of fractions, P over Q, where P and Q can both be integer, but of course we can't divide by 0, so Q is not allowed to be equal to 0. The notation for the set of fractions is a Q, and an alternative description is the rational numbers. Now, the fourth extension of the fourth number system that we want to discuss is in fact the set of reals, which are precisely the fractions plus the wholes in the fractions. So the symbol for the reals is R, and we get them by filling up the holes in Q. Now examples of such wholes are the number square root of 2, pi, etc. Next I would like to discuss sets and relations between sets. Now what is a set? Well, a set is simply a collection of points. As an example, you can think of, say, the collection of fractions and the collection of natural numbers. We have seen these before. Of course, we can have a certain relation between sets. One set can be contained in the other, and we know it by the symbol. For instance, the natural number is contained in the set of integers, which in turn is contained in the set of fractions, and this is contained in the set of real numbers. Now another relation is called intersection, denoted by this symbol. How can one view what an intersection means? So say that we have two sets A and B. Then the intersection of these two sets is the collection of points that they have in common. So how can we formally describe this? It is the set. The intersection is the collection of points X, which belong to both A and B. A further symbol is the symbol for union of two sets. Now what is the union of two sets? It is the collection of points which belong to either one of them. So denoted by this green area. And formally we can describe this by a set of points x, where x belongs to either A or B. Now clearly, in taking an intersection, we can have the problem that the sets involved have no points in common. Now, to describe this, we say that the intersection is the empty set, and the symbol for empty set is this one. So in this case, the intersection of A and B is the empty set. Now there are very special sets in R, which are called intervals. Now we have various types of intervals. So intervals is a closed set of points. So let us specify two numbers A and B, A smaller than B. Then the points between A and B can include the endpoints A and B. And this collection of these points is denoted by as follows, by writing the numbers A and B with square brackets. Formally, we can describe it as the collection of points x, where x is greater or equal to A and smaller or equal to B. Now obviously one of these endpoints may not necessarily be an element of the interval. So for instance, A does not belong to the set, but B does, and we denote it by this open circle. A closed circle means that the corresponding point does belong to this interval, and so we denote it as follows. Now we write a round bracket at the endpoint that does not belong to the interval, and we can describe it as the points x, where x is greater than A and smaller or equal to B. Now of course we can now make any combination of the two. We can have an interval where A belongs to the interval but B not, or we can have the open interval AB where neither of the endpoints belong to the interval. Of course, an interval may not have two finite endpoints, so to speak. For instance, there can be a point A which belongs to the interval, but otherwise we take the whole set of real numbers larger than A, and such an interval is denoted by replacing the endpoint B by infinity and writing a round bracket. So we can formally describe this as the set of points x in R, where x is greater or equal to A